Find the answers to questions you may or may not have asked yourself. Here at Kaleidoscience, Conversations on Cognitive Science.
This is a somewhat special episode because for the first time in a regular episode, Imogen is co-hosting. You may have heard her already in the Christmas special, but now she also hosted a regular episode because we really had trouble scheduling the episodes and she was friendly enough to help us out hosting. Enjoy the episode. Welcome to the second episode of our blog on the topic of music. And last week we already talked about music and attention, but we only talked about how we can maybe subjectively or with computers measure the performance of music, but we never talked about the generation of music. And today we will talk to Professor Kai-Uwe Kühnberger from the University of Osnabrück. And he has specialized in the field of generating and analyzing music with the help of artificial intelligence.
Thank you.
Yeah, thank you so much for being our guest today.
I have to thank that I got this invitation to talk about AI and music here in this podcast.
We will start out the episode with our usual get to know game. So now we will give you 5 questions, and your task is to answer them as spontaneously as you can.
That's dangerous sometimes.
Yeah, that's the fun of it.
Okay.
As a kid, I always wanted to be
Beethoven.
Oh, interesting.
I can give a reason for that. I think, well, as a kid, probably it's a little bit over exaggerating the whole thing, but I think Beethoven was a composer who was fundamentally different to many of his predecessors and many of his successors. Because if you take Bach, for example, or Mozart, or these classical tradition in Western music, then they are somehow people who stick to their epoch, to their style, right? And Beethoven was, I think, someone who was one of the most innovative and most creative composers. If you hear the second movement of the 32nd piano sonata, then you have a ragtime there. Ragtimes were invented 100 years later, or something of this type. A little bit less than 100 years later, but and then I think the degree of creativity and the degree of originality and the degree of novelty is very very strong in the case of Ludwig van Beethoven. And I think he's relatively unique in this because I think the next composers who were also trying out something completely new, something completely innovative, and somehow breaking with their tradition. This happened, I think, later in the 20th century, with Charles Ives and some 12-tone music and these traditions. But Beethoven was really someone who was one of the most original, most innovative composers I think you can think of.
That's super interesting. I'm not that versed in classical music, so it's really interesting to hear from someone who definitely is. The second question is, if I was an emoji, I would be?
Hopefully a smiley emoji.
Nice.
Hopefully.
And the third question is, my favorite thing to do on a day off is?
Playing the piano. Most times this is a lot of fun, I think. And this is also a very relaxing task, a relatively relaxing hobby, in my opinion. And it's something completely different in comparison to what I do the whole day. And in so far, it's a nice hobby and a very nice thing to do. I'm not so sure if it were the same if I were doing it professionally. So because usually if you do something professionally, then you are very lucky not to do this also in your free time in a certain sense. And so far, I'm not sure whether this would be true in this case. But playing an instrument is a very nice thing. I can only recommend it to everybody.
Yeah. Yeah, I'm playing the violin myself, so I know the feeling of just like focusing on the music and like reading the sheet music and zoning out from everything else that usually goes on in your mind, especially like after work or something like that. So yeah, I can really relate to that.
Completely agree. Completely agree on that. Yeah.
All right. The next question is right now, I'm most fascinated by.
Well, professionally speaking, I think the thing that fascinated me most in the last 5, 6, 7 years was the rise of transformer models in artificial intelligence, because I really think that transformer models are something qualitatively new in comparison to all these 1,500 other models that exist in the last 60, 70 years of history of artificial intelligence. And you had for decades, you had the situation that artificial intelligence was very good in improving tiny little details in some application, and you developed very specialized systems that were really good in solving very particular problems. But the interesting thing was that they were unable to do anything outside of this domain. So AlphaGo, for example, was able or is able to play Go, but but the system cannot play chess, for example. And I don't want to talk about processing natural language or producing music or finding some objects in images also. And this highly specialized AI was all the time a very, very successful story. So people said there was several winters of AI, and AI was dead several times in its history. I had never the impression that this is really true, because in their specialized domains, there were many, many AI systems that were really, really good, what they are intended to do. Now, transformers are in so far completely new, in my opinion, because it's the first neural approach that relatively convincingly can model context and has a certain form of memory to a certain degree, at least. This was all the time a very, very clear problem in all neural approaches. You cannot memorize anything. You cannot take context into account, and people tried hard to solve this with LSTMs and with recurrencies and what have you, but it was not really successful, in my opinion. And then transformers suddenly were able to do this in a very, very convincing way, and that was one thing that was extremely interesting. And the second thing that is, in my opinion, also relatively new is that transformers are the first model that can do in a reasonable way transfer learning, and can be fine-tuned in domains they are not pre-trained for. So you pre-train a transformer with natural language. It's very good in language production and language generation. And then you fine-tune it to detect objects in an image. Now the question is, what does a pixel stream or a pixel two-dimensional array or something like this? What does pixels have to do with the sequence of words in a natural language? First of all, not much, I think. And nevertheless, it turns out that if you take a natural language pre-trained language model, let's say, and you fine tune it for object recognition in images, then it turns out that it's significantly more efficient to train, and it's significantly better concerning accuracies than a non-pre-trained transformer. And this is interesting. And therefore, I have, in my opinion, the transformer models are something new, which is different from many approaches that were proposed so far in the past.
I already want to ask more questions about what you think about Transformers, but we have a lot of questions about music, so I'm going to
Okay.
continue with the next question
Mhm.
of the Get to Know game. I know it's time to call it a day when.
So usually when it's I like to work in the night. But the interesting thing is, as long as I'm concentrated enough to not fall off the chair and can write a reasonable sentence still in an email or in a text or so, then it's okay. But usually at 12 o'clock at midnight, then usually there's a certain borderline reached, and then I stop this usually. So that's kind of a very usual pattern, I think. But there's nothing deeper concerning this. So usually, what I no longer do actually, when I was young, I even had dreams about science actually. So solving some formal problems in dreams. This was something that happened when I was a student, or then later in the PhD time. But this is completely gone, I must say. I don't know whether this is good or bad. I have no idea, but definitely this is gone. So
Interesting, yeah. Okay, so now we want to learn more about how you got into the area where you're currently researching. But first, let's start at the beginning. How did your scientific career start?
probably as science starts probably. Science starts probably when you enter university, I would say, because that's your academic education, that's your scientific education. Here, probably many things in this direction start. I was as a high school student. I was relatively interested in physics. I would say, in particular, high energy physics, and in philosophy, and in music. Actually, that what were the three main things I found very interesting. Actually, not on a scientific level, because in high school, as a high school student, you are not a scientist usually, but I was interested in these three fields. And then during the civil service, I decided to study music actually, and I wanted to become a composer. At least that was my wish or my desire at that time. And then during the civil, and then I took some courses at the music or the music department of the Musikhochschule in Stuttgart, where I took some classes about music theory and then Gehörbildung. I have no idea what that is in English actually. And I played a lot of piano, and I tried to be as good to pass somehow the exam you have to take when you want to enter a music university. And then I got a kind of an injury in my wrist, and then this was over, and then I had to do something else. And then probably scientific career, I don't know, but the scientific orientation started, because then I had to decide to study something else, not music any longer, but something else. And in music, it would not be a scientific career; it would be more an artistic career. But then I decided to study things like mathematics and philosophy and linguistics. And then I entered first the University of Stuttgart, and then later the University of Tübingen, to do the studies there. And this was definitely something I found very, very interesting. I was fascinated by formal systems, in particular logical systems, because it was possible to do logic in philosophy, it was possible to do logic in algebra and mathematics, and it was possible to do logic in linguistics, in particular in formal semantics, which is more or less nothing else than a logical theory. And I think at this point, science became more important, and I thought, in a vague sense, would it be an option to do not really work in the world, like working for a company or so, but do you want to do something like science in the future, right? So, and then I decided, because probably there were not, it was kind of possible to do this. After your graduation, you entered PhD program first in Tübingen. Then I was 2 years in Bloomington, Indiana. Then I came back to Tübingen. I finished in Tübingen because of personal reasons. And then I got at a certain time point, I got a PhD in computational linguistics from the University of Tübingen. And the interesting thing was then, because here still, or at this point, you can do something else, right? You can decide, oh, I've stopped the scientific, academic, strange thing. I don't know, you enter a company. IBM was one of the big employers at that times for computational linguists, for example, and they had to have their German headquarters in Böbling, which is just a town very close to Stuttgart. And many people did that, actually, from my colleagues from that time. At this, I asked my PhD supervisor in Tübingen whether he would recommend that I continue somehow this academic degree with a postdoc and things like that. And then the interesting thing is, he did not say something like yes or no or maybe or so. I think he talked at least 10 minutes, and I felt it for me it was more half an hour or so. And his speech was full of metaphors and complicated, and I didn't understand what he wanted to tell me. But at the end, I was pretty sure he did not say I should not do it. He did not. I was pretty sure about this. He did not say that I should not continue this. And then I decided, well, then try to do a postdoc and do the scientific path, follow this scientific path. Whether it was a good idea or not, I have no idea. But that was somehow by accident happening.
And how did you end up in Osnabrück?
This was kind of an accident, because we had a research unit. It was a distributed research unit funded by the DFG, University of Tübingen, and then some other universities. I think Bielefeld was a part of it, and the IDS, the Institute für Deutsche Sprache in Mannheim, I think was involved, and I've forgotten all the locations. And we submitted a proposal, and we had to submit the full proposal for this research unit, and this was delayed because some people didn't came up with their projects and stuff like that. And my position was a temporary position in Tübingen, and at a certain time point, when the time interval is over, you have no longer a job. Right? And because this other project finally it took several more months, or even half a year, or even it was later. I've forgotten the precise dates, but then I had to look for another job, and then there was a possibility to go to Osnabrück, and then I went from Tübingen to Osnabrück. And then I entered Osnabrück, I think, in the year 2001. And then in 2003 I became assistant professor, and 2009 a permanent professor, and then I never left. So that was probably the story. But in principle, there was not a big plan or anything like this, because these things all the time happen quite often by accident or by certain circumstances you cannot influence. It's just happening, and you react in an appropriate way, I think.
Okay, yeah, really interesting. And so during your, in your scientific career, if I understand it correctly, you were more going into the direction of linguistics, language processing, and so on. How did music come back into the mix?
So the transition from computational linguistics to artificial intelligence, this is not a big step or was not a big step, or is still not a big step today, actually, because in the late 90s and the early 2000s in Germany, when artificial intelligence, was more or less either doing computational linguistics or doing some kind of, theorem proving, or doing something in the direction of neural network learning. That were the three things I think that existed more or less in Germany. And they were relatively prominent with relatively large projects, and so to do a transition from computational linguistics to artificial intelligence is perfectly fine, in my opinion. That is something you can all the time do. And if you think about the importance of NLP systems, natural language processing systems, in current AI systems, well, that's why AI is so popular, right? Because you have these large language models. Now, and then we did at the beginning here in Osnabrück, there was a lot of work done in ontology design, that is more or less hierarchies of concepts in a certain sense, and ordering somehow the conceptualization of a certain domain, so to speak. So I don't know, Socrates is an instance of a human being. A human being is somehow an animal. An animal is something like a living being. A living being is something like everything or something or whatsoever. So you have hierarchies here, and the other thing was kind of more logic-based modeling of cognitive abilities. Cognitive abilities means here things like we are able to establish analogies between two domains. For example, we can understand metaphors in natural language, things that are extremely hard for computers usually and formal systems. So we did this in more or less, and then music was not a topic at all, actually, and we started to think about music by an accident. Because again, everything is just accidents and circumstances, right? There's no plan behind this. So the first thing, we had some collaborations with some people in Barcelona, with some people in London, and with some people in Thessaloniki, and some other people. And we wanted to apply for a European Union grant in a call that had to do with creativity. So we wanted to understand what creativity is, right? And then we had some ideas about the formal specification of these things. We had some ideas how you can build models of creativity and things like that. And we had in London a real expert in creativity research there, also an AI person. And then we needed 2 application domains where you can really test the framework. And then one was relatively fastly identified, based somehow also on the competencies they had in Edinburgh, which was also a partner in this European Union project. And this was mathematics, right? And then we thought, okay, we need a second one, something different from mathematics, something that is not so formal, not so technical, not so precise, perhaps. And then we thought about art, paintings, stuff like that, about literature, perhaps, right? Poems, dramas, novels, I don't know. And then someone came up with, what about music? Right? And then we thought about this in a big group. I think this was decided, if I remember this right, around 2012 or 2000. It was the year when the European Conference of AI was taking place in the south of France, in this one city which is called Montpellier. In Montpellier was this conference. And I will never forget this. We just had lunch, actually, a relatively long lunch with a larger group. And I think during this lunch, we decided that we want to do music. And then I suddenly had to remember or to remind myself, well, music played a lot had a certain importance in your former life somehow, because I forgot this already in the meantime. And then I became interested again in music, and this was Again, kind of an accident because it was triggered by a European Union project. These projects are relatively short. They are just for 3 years, and you cannot prolong it and continue it because they are just kind of a closed shop. And after 3 years, it's over in a certain sense. And then I started to think, to think again about music. This was the starting.
Okay.
You already touched on the topic of creativity, and I think we already had a past episode on the topic. But today you hear like the transformer models you mentioned earlier, that they are like work just like autocomplete. So they have seen like a lot of texts, and then they can reproduce the text basically in a way that makes sense for us. Have you found the same thing for like all models of creativity, and especially for music? And if there's even like a correct assessment, so is there then creativity as a result of that, or is that just like, oh, that just reproduces something and the model is not really creative?
Yeah, that's a hard question because nobody really knows what creativity really is. So even if you ask psychologists or some artists or some people, whoever you want to ask, they will come up with relatively different definitions or specifications what creativity really means. The first thing that is a problem is what can be creative, right? So is it the piece of art? So is it the piano piece or the movie or the drama or the poem? Should be called this creative? Is it the artist who produced the piece of art, or let's say a scientific theory? So is the person behind the whole thing is this person creative, or is it perhaps the whole process in producing a piece of art, in producing a piece of music, in producing a movie, or in producing a new scientific theory? Should the process be called creative, or is it all three together? So this is the first problem. People disagree usually. In my opinion, all these things come together in a certain sense, because you shouldn't separate or isolate it to a single person or to a single piece of artifact or something like this, or to the process alone. It's the whole thing together, I think. And then clearly the question is, what are the specific features why we call something like this creative, right? So is it a novelty? Probably not, because computers can do random nonsense, and this is definitely novel, because probably never ever in the history of the universe something like this existed before, but we wouldn't call this creative. It's just not, I don't know, nonsense, right? But definitely novelty is something you would is a necessary condition for creativity. But additionally, you need probably something else. You need probably kind of what I call what could be called a market. Now, clearly not just in the economic sense, but something who somehow is a recipient of this piece of art, of this novel, of this music, or of this movie, or whatsoever, and somehow can assess that this is an important piece, or it can assign some value, some importance to this, right? Because without this assessment, it's hard to say that something is creative, right? If nobody ever is a recipient, if nobody reads the book, if it more or less does not exist, right? So probably you need something like a market, something that people honor it, some like it, something of this type. And then clearly creativity means also have this feature, in my opinion, that the novelty lasts for a certain duration or in time interval. So it shouldn't be the case that two people like this piece of music or this image or this, I don't know, this movie, and then it's gone, and then everybody thinks it's nonsense. It should have some prolongation of people somehow can assign value to it. And if things like this exist, then probably you can say, okay, something is creative and the artist was creative and the process in producing it was creative. By the way, what is also interesting is if someone produces a scientific theory or a piece of art or so, and then people say that this is creative, quite often the artist or the scientist, they can somehow give hints how they ended up with this new original idea. So in scientific theories, you can rationally reconstruct what people did in order to come up with a new interpretation, with a new model, with a new approach, for example. Also, if you ask a musician, what are you doing when you are composing music, or when you are, I don't know, writing the music for a Hollywood blockbuster, or I don't know, or pop music, whatever. Then usually I think they can, for many pieces, they can really precisely say what happened when they did this. It's very metaphoric. It's kind of very accidental again, but usually they can say something. They can reflect on this, and they can rationally reconstruct what they did when they were in this process of producing something. And this feature is also something that fundamentally distinguishes human creativity from artificial creativity. Because usually if you ask a large language model why you came up with this, then it's on a completely different level, this explanation why, I don't know, the decision was made in this and that way in a large language model, or the transformer was producing this type of music also. So the creativity concept is a complicated one, relatively difficult, and I would say to a certain extent, artificial systems can simulate creativity, although will definitely not show we shouldn't assign a type of creativity that is equivalent to our creativity. But I think they are really good in simulating certain things. It's a little bit like emotion. So if you have a little robot who smiles to you, and sometimes the robot is angry, or the program or whatsoever, right, and shows emotions, then sometimes you can do this. It happens in a way which is relatively convincing. But that does not mean that the program or the robot has emotions. It just shows that it can simulate emotions that seem for us to be emotions, but in fact they are not. Right? And in this sense, I would say simulating creativity with artificial systems is possible. Real human creativity with the artificial system is not really achievable currently. I have no idea what this should mean at all, actually. That was a long answer, probably. I don't know. But
No, it was great. It was really in-depth explanation of creativity, or what you think of creativity.
I mean, we had a whole episode on just the topic of creativity, so this was definitely shorter than that episode.
Okay, that's good. Yeah, okay.
You said that AI can simulate emotions, and you also said that for there to be, or for work to be considered creative, it needs to find like an audience. And in the last episode, we also talked about like rating musical performances. Is there a way, or are there models that judge just music? So could there be like a back and forth that like humans generate the music? So we always just talked about like the AI generating the music and the humans listening to it or not. But is the other way around also like research? So is there like research on just judging music or musical performances?
Yes, definitely. And actually, in this European Union project, one of the big questions and one of the big tasks, also because the call of the European Union was about creativity, right? And one of the big issues was evaluating creativity, right? So the system produces something. Is it creative or not? Very, very coarsely, not very fine-grained described. So one task was somehow to find models or train a system in a way that you input some type of music, and usually that were blends of. So we had some systems that were able to blend many different music styles. But the outcome is relatively strange sometimes. So you have to consider you blend a Greek folk music, which is hard to hear, by the way, for our ears, but Greek folk music with I don't know, some type of Baroque Bach music or so, and then you get a relatively strange outcome actually. And the task was somehow to find a possibility where you are able, or where the system is able to assess in various dimensions, in general, the quality of the music, but more fine-grained. So not just this is good or this is bad or this is creative or not creative, but somehow the level of innovation, or the level of originality. And clearly also some more general assessments. Well, is it good or is it bad, and stuff like that. And the setup was somehow like this. So you had in Thessaloniki there was a music school where all the undergrad students had to rate all these types of music, and then you had kind of a psychological tendency that musically educated people would assess this as this and that. And then the task was somehow to build a system, an artificial system that come up with the same assessment in a certain sense. And this turned out not to work at all, I would say. So it was just extremely hard actually. So rating musical performances, rating the quality of music, rating even rating just in a sense that you say a particular piece of, let's say, automatically generated music sounds better to the majority of people than something else. Well, if they are far away from each other, this is relatively easy. But if they are very close in one genre, this is extremely hard, in my opinion, because there are no good frameworks where this self-assessment or this what we intuitively know actually, and we also I don't think so. If you hear a piece of music and you like it, you don't think of and analyze it and think, well, because it, I don't know, used the double dominant here and not the dominant, and then there was this fancy harmonic progression, or this change of rhythm in this part, or this particular bass line sounds very good. So you don't analyze music, you just like it, right? So you have an intuitive understanding. I like this piece of music. And this is something artificial systems are not able to do, first of all, right? So they just work differently. And on this level, you cannot assess this. And in so far, there's a lot of research, I think, going on concerning these assessments, ratings, and things like that, concerning performances, concerning compositions, concerning creations of artificial systems. But what they usually do is, I think, they try to simulate what humans usually, or how majority of humans assess it. That's usually how it works. But there's no deeper system behind, which somehow in a specified way and in a principled way somehow can compute why this is good, bad, nice, better than something else, etc. But a hard question, in my opinion, and a very interesting one for the future, in my opinion.
Okay, so just as like a small summary, if I understood it correctly, so current AI models that try to assess the quality of music basically try to predict the response of humans to music.
That's the easiest way, because this is you can just take label data with assessments of human beings, and then you train it, and then it will find patterns why something is usually considered to be nice. But I would like to have a system that really has an own explanation. So not just a massively data-driven approach that majority of people usually like this, but I would like to have a system that explains to me why a particular piece of music is good because of these and that musical features it has, for example. Or it can be also some other types of features, probably. It might not necessarily the classical musical features we talk about when we take music lessons or so, but some type of explanation. And this seems to be relatively hard, I would say.
You just mentioned that this way of training is like the easiest way of training because you have like the human ratings and that is good data. But
Mhm.
then in general, how does like generating or also rating music take in the music? Because I think like now everybody has like a streaming dienst like Spotify or something, and there are millions of songs. But does like just the waveform of the song make a
Mhm.
good input for a model, or should there be like the written down notes of the song and
Mhm.
maybe the lyrics? So or is it
Mhm.
just different from model to model? Is there a good way of generalizing?
Well, the class, the easy, so there are, well, both is possible, or all these things are possible. But historically, it turned out to be much easier to take the MIDI files as input and not the audio files, because audio is very much more complicated to analyze for artificial systems than MIDI, because MIDI is relatively structured. You have certain tracks, and on these tracks you have relatively clearly specified. I don't know if you have a piano when the pitch starts and when the pitch is released, and and then you have these formal specifications in a very structured way. And training a system on these MIDI files turned out to be much easier than on audio files. And therefore, the first system, so Die Bach, for example, and also the older systems in the early 2000s, because these things exist for many decades now. But in the recent development of, for example, Die Bach and the very so-called variational autoencoders, or even hierarchical autoencoders from Google, when they developed this, they used first of all MIDI files. Now, but the harder question is to use audio files, because that's a more natural way, because we don't get as an input a MIDI file. When we hear music, we get an audio wave, right? And then our brain is somehow interpreting this somehow. How this works, actually, also nobody knows, but this is our reality in a certain sense. And the audio data turned out to be much later. And what people do when they train systems on audio data is usually, and also here you have all the systems are deep learning systems, more or less, and currently clearly transformer models are very prominent as everywhere, but they are not the only system. So you can also take other deep learning models, like GAN systems are relatively important, and autoencoders and some other frameworks. The interesting thing about MIDI files is that MIDI files can be also, you don't need, or let's put it this way, you don't need necessarily deep learning approaches to train something with MIDI files. This is also possible with completely different frameworks. So, for example, a classical way was using genetic algorithms, for example, for training a system to produce music. Or also some relatively simple, the simplest way are Markov processes, which was relatively prominent in the early 2000s, 2000, I don't know, 5, 6 or so, perhaps with additional constraints, perhaps even with a certain degree of memory, and one reason why currently transformers are relatively important, or probably more important than other deep learning approaches, has again to do what I said at the beginning, that they are able to model or they are able to model context, and they are able to model memory. And this is very crucial for music, like in natural language. So in natural language, you have a text, and there is either a discourse referent. I don't know. Peter was introduced a page before, and then the next page it was the personal pronoun he refers to Peter. You have to remember something in order to identify what he means, right? And in music, you have a very similar situation, because at least in Western music, popular music, and things like that, usually music is written in a certain tonic, so some kind of C major or so, or G major or A minor or something of this type. So you have a certain scale you have to use. This can modulate, this you can depart from it, this can change. There are many possibilities here, but nevertheless there's a tonal basis in a very strong sense. In Western music we like to hear. There are clearly also there are types of music where there's no scale, but usually they are much more exhaustive to listen to it, because they sound a little bit more difficult to hear to it. And now the important thing is, if you had no memory, it would be extremely difficult to start in C major a song, and 3 minutes later it ends in C major, because you have to memorize this. You have somehow, you need somehow, and the interesting thing in music is, like in natural language, you have the long distance dependencies in very different, on very different scales. So clearly your current situation is important for the next transition, or the next chord, or the next continuation of the melody or so. But clearly, it's not only your current state, but it's also, I don't know, 2 bars before, or 3 bars before, which is somehow crucial how to continue now. And because of this necessity to take context and memory into account, in my opinion, transformers are relatively well suited for this domain, because they can model these things relatively convincingly. And not exclusively, because clearly, I don't know, LSTMs were for already 10-15 years ago used in order to do music production, but they were not as successful, simply, right? And that is one reason why I think transformers are important in this development of music generation.
Maybe just a quick question in between. I heard that one approach for speech processing is to turn the audio files into images of the sound waves, and then to train an image model on that. Are there similar approaches already done for music?
Yes, this is standard way to do it. So what you do essentially, you have an audio file. You somehow separate this in a time series of spectrograms. These spectrograms specify the different features, and then you train somehow. You can also use a CNN. It's not necessarily only a transformer, but you need some kind of deep learning approach in order to interpret this. And this is the usual way how it works. Yes. And this is with music not different to speech recognition, for example. And it's, by the way, even if you go to a very technical domain, like, for example, we had a PhD thesis some years ago where someone was trying to well, the problem is, in a certain sense, if you have a modern car, it's full of electronic and computer power and, very, very smart systems. And so. But still, there are some things that seems to be difficult. So one is condition monitoring. So somehow the problem that the car itself decides when some part of it needs maintenance, for example. Right, so is the wheel still properly fixed to the car, for example, or is there a certain injector? Is it very close to being damaged or so? So if you have this maintenance issue, in order to do this, and in order to do some other things, there are possibilities either to in this case, for example, to use sensors for vibrations. And if the characteristic vibration is different, then usually something is different to the regular situation. And another thing is to use micros, so microphones, so to somehow record somehow the sound, right? And you can do very interesting things with microphones. So, for example, you can and you can train systems to do this. You can record, for example, I don't know, the sound when a wheel is just rolling over a street or so, and then you get characteristic feedback if it's wet, if there's snow, if it's cold, if it's warm, if it's a flat surface, or if it's kind of some strange path in the woods, or something of this type, right? You get this relatively significant audio data about this. Another application is, and this happens quite often. So if you are in a car or on the bike, for example, and then there comes an ambulance or a police car, and then usually, first of all, you don't know where is it, behind you, in front of you, right or left. You usually cannot distinguish, or you cannot identify the direction usually. One idea was also, for example, to use microphones in cars to immediately identify where the sound comes from. Things like that, right? And the interesting thing, all these things, all these vibration sensors, the microphones with the audio data in cars, they are working precisely the same like speech recognition or music, right? It's just a time series of spectrograms, which are trained in a very characteristic way, and the artificial system, or the dependent on the CNN in the classical sense, or the transformer model, is just somehow deciding you are now, there's snow on the street, or it's wet, or the ambulance comes from the right, or my little injector is getting out of order, and things like that, right? And they work the same way as speech recognition and music analysis, essentially.
That's super interesting. I did not think that cars would be an application area where there would be such a huge similarity.
I think this is not so surprising, because it's more or less the type of information you get, right? And if it's a kind of an audio data, then usually the processing with an artificial system is very similar, and whatever that audio data is, right? If probably you can do the same thing with, I don't know, with explosions, and you can immediately say this is a firework rocket, or this is a kind of something more severe, I don't know, a little bomb or so. So probably these things are relatively characteristic, and systems can be trained to detect or to recognize this. But the interesting thing I found very interesting is that more vibration sensors are also somehow very similar to this audio data in a different scale, on a different scale, and they work a little bit different, but more or less you can use the same systems to do this. And this is you have data, and you need to analyze data, and then you have certain possibilities to do this, and sometimes they are relatively close to each other and very similar. That's true.
And I have one final question on the type of data, because earlier you mentioned MIDI files, and if I remember correctly, that is a standardized way of dividing music into tracks, I think. And now we are talking about audio data, but then all the tracks are mixed together. Is there a problem maybe in the judgment and generating of music artificially, because there are these components that are stacked on top of each other, or is that not a problem at all?
Yeah, well, classically, this was one of the major problems actually, to disentangle, so to speak, the different. So I don't know. You have a pop band, and you have two guitars, one bass, one percussion, one I don't know, one singer or so, something of this type, right? And the one keyboard or so. And then usually you hear a holistic sound, right? And if you have just the audio data, the big question was all the time, how can I disentangle this, that I get the track of the percussion, percussions, or the guitar one or guitar two and so on. This turned out to be a relatively complicated problem. And therefore, what people did when they do, for example, genre classification, so I don't know, I'm not so good, an expert in popular music, but I don't know. There's rap music, there's house music, there's classical rock, there's heavy metal, and death metal or whatsoever, right? So there are different genres of popular music, let's say. And interestingly enough, although they were not able to distinguish these different tracks, they were nevertheless able to classify particular pieces relatively well. And the reason for this is that for many genres, just the percussion, the rhythm, was relatively characteristic in which genres this should be classified. So if just a system focuses just on the rhythm, which is relatively easy to detect in comparison to other things, then they were already relatively successful. You are right. So with MIDI files, you have a highly structured representation of the music. That is true. And this is still relatively complex, because if you have a complex piece of music with many tracks, or with a symphonic orchestra, so you have many different things you have to take into account. But the biggest problem in the case of the audio file was definitely to distinguish these different tracks. And what classical systems today are doing is something different. They do not separate this, but they take the spectrogram in the different frequency as a whole. But because of the frequencies in the spectrogram, you have already a kind of a distinction between different parts of music in a certain sense, right? And this is sufficient then finally to detect, or to identify, or to learn the patterns that are behind, so to speak, the musical piece. And immediately when such a system identifies the different patterns of a musical piece, or a certain genre, or a certain tradition in music, it is not so complicated to use it for generation again. So
We have already talked about what the models in the past looked like, but how do you see the future of AI and music?
So currently we are in a situation where we can, to a certain extent, automatically analyze music, right? We can do this to a certain extent. So it doesn't work perfectly. It's not just the case that you get an audio file and then suddenly you get the sheet music out of it. It's not so easy. But to a certain extent, this can be done. To a certain extent, you can put in a MIDI file, and then you get a harmonic analysis of this system. At least in the Western tradition. I usually talk about the Western tradition, not about Chinese opera, because I know nothing about Chinese opera, and I think Chinese opera is kind of different concerning the pitches and the type of how this music works. But for the Western tradition, I think you can do this. You put in a MIDI file and you get a complete harmonic analysis, which is probably not really worse than if a musicology professor would have analyzed it. I would say, I would be my guess. So these things work quite well. And then there's now this feature that is on Spotify, or these streaming services. You find more and more artificially generated pieces of music, and there are at least people who like this, and who hear this, and there are companies behind this, and there are companies that probably want to earn money, or already earn money. I don't know. So the big question is, what will happen in the next 5, 10, 15 years, right? So does that mean that the next Oscar is not won by, I don't know, John Williams or Hans Zimmer or whoever, but a certain AI system. OpenAI produces a new model, and then suddenly this model gets the Oscar. Or is it more or less a different path, which results in a situation where, for example, the working musician uses such AI systems to get more creative? And I tend to think in the second tradition and not so much in this first tradition, because in my opinion there will be also in the next years no systems that completely autonomously do everything in such an area. They are helping tools because you can relatively fastly generate ideas by these systems. You can fastly say, oh, this is what I do not want to do because I don't like it, for example. You can very easily technically transpose just something into another mode, for example, or into another scale, and you can modify it in a certain so compute very easily variations. So if you think, for example, about film music, I'm pretty sure that the employees, Hans Zimmer's employees in Hollywood, most of these people are doing nothing else that composing variations of, I don't know, these 5 major themes that exist for one Hollywood blockbuster, of like perhaps 7 or so, in a Hollywood blockbuster, they have 20 different versions of it. They're completely with different instruments, different rhythms, different tempi, different styles, complete modulated in a very interesting way, um, and um, and all these things can probably be done semi-automatically, not completely automatically. I don't think that this is currently possible, but semi-automatically. And then you get much more efficient in what you do. And I'm pretty sure that even your creativity could be higher if you use such systems in the future. So this is where I think the whole thing has a tendency to continue. They completely, so the all these fears that now artists are suddenly lose all their jobs and become unimportant, and I don't think that this will be the nearer future. At least I don't know what happens in 50 years, but in the next 5 to 10 years I don't think that this will happen actually. But the future, but people think about this. And by the way, another interesting question for the future is dependent on the degree of usage of artificial systems in producing some piece of art, let's say, or in producing a scientific theory, for example, or in producing some kind of I don't know, a text novel or some non-belletristic book or so. The question is, who has the copyright for this? So when is the point where you have so much artificial intelligence in there that you need to assign partially, at least, some copyright to the artificial system? This will be a question, in my opinion. And because it is already possible that some chatbots are some co-authors of scientific papers, I could imagine that questions like this will somehow get more important. Currently, as far as I know, neither North America nor the European Union, you can assign a copyright or anything like this to something produced by a non-human. So all the time, the creator must be a human being currently. Whether this will last for the next 20 years, I'm not so sure, I must say.
Yeah, very interesting and certainly important considerations.
And now that we have looked in the future of music generation, we will now look slightly in the past of this podcast, because our podcast started at the University of Osnabrück as a cognitive science podcast. We have now also invited guests from outside that field, but you are now back as like a professor of cognitive science. So we would like to ask you, what role do you think cognition plays in what you are doing?
Very good. Very good question. So the interesting thing about artificial systems, in my opinion, at least in my conceptualization, is that I think about artificial intelligence all the time as something which is cognitively inspired and cognitively motivated. So this is relatively trivial, actually, because artificial intelligence has to do with all the cognitive abilities we have and we just assign to us. So we can follow strategies, we can talk in natural language, we can somehow plan something, we can perceive the environment with audio data, with visual data, and so on and so on. And this is precisely what artificial system should be also able to do. So it's cognitively inspired. Now, if you ask concerning this particular systems, is there a lot of cognitive inspiration in the building of these systems? Then the interesting thing, in my it's probably a little bit frustrating, in my opinion. I really think that many of these formal approaches, for example, what we did about analogy making and conceptual blending, and and also conceptual spaces, and then all these things, I think they are relatively technical, very mathematical, but I think they are in principally cognitively inspired. I also think that many of the neural approaches, so in particular, for example, things like CNNs, for example, have a certain tendency to be cognitively inspired. I definitely think that this is true. And the most frustrating thing is that I have not the impression that everything transformers are doing have any type of cognitive inspiration. Clearly, they talk also about attention, heads, multi-attention, self-attention, and so on. And clearly, attention is important for human beings. That's true. But technically, what these systems are doing is so different from what we understand, what the concept attention means, that I do not have the impression that this is cognitively inspired. And if you look on these architectures, if you look at the positioning system to, for example, massively parallelize the input and to artificially code in which where this particular token appears in the long sequence and stuff like that. This is all that has nothing to do with cognition. That is complete, very, very, very smart engineering, but is completely cognition free in my interpretation. I'm pretty sure that there are people who disagree with this view, but I think, and the frustrating thing when I read some articles about transformers some years ago, and I was fascinated by this architecture. Was also many AI systems are really at least cognitively inspired, and clearly technically they do something else than the brain or what we usually do in cognitive science, but they are at least inspired. With transformer architectures, I had not the impression that they are really cognitively inspired, and nevertheless they are so good. And this is somehow kind of frustrating, in my opinion, because I would have hoped it would be different. But okay, that's at least my current interpretation of the situation. But nevertheless, to come back to your question, I think cognitive inspiration and cognitive orientation in building models was for decades, and still is, I think, very crucial for artificial intelligence in general. And that this comes in degrees. Sometimes it's stronger, sometimes it's weaker, sometimes it's more obvious, sometimes it's more hidden. That's also clear. But without cognition, I would say, without cognition, there wouldn't be anything like artificial intelligence.
Yeah, that was a very interesting answer that gave me also a lot to think about. If someone has listened to this episode, and I think there were like a lot of interesting bits in it, but is there something that stands out to you where you think like someone who listened to this episode should take that away from it?
Well, the important thing is, in my opinion, that artificial intelligence is also entering the field of music. And I'm pretty sure that the simulation of very interesting pieces of music is possible already now. It will be even better in the future. And at a certain time point, we hear a lot of artificially generated music, and we will not recognize that it's not a human who composed and performs it actually as well. So
All right. Yeah, thank you for that answer and generally being here with us today. Thank you very much. It was a lot of fun for me.
Yeah, it was super interesting.
Thank you very much, and yeah, all the best.
You've listened to Kaleidoscience, Conversations on Cognitive Science, hosted by Elisa Palmer, Sönke Löw, and Sophie Kühne. Produced by Clara Kühne, Imogen Hüsing, Elisa Palmer, Leslie Volk, Sönke Löw, and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science. This podcast is not sponsored and does not give us any financial profit. If you wish to support us, the most effective way is to do so by leaving us an up to 5-star review on your chosen podcast platform and following us on Instagram. You can reach out to us via mail, comment on YouTube, or message us on Instagram. We are always happy to hear your feedback. Thank you again for listening to us and for your interest in science. If you have any questions regarding this episode or any of our other episodes, feel free to reach out. You can reach out to us via Instagram by sending us a direct message at kaleidoscience_pod or write us an email at kaleidopod@us.de. You can find both links to our Instagram and also the email address in our show notes. We do read all your comments and will also reply to you as soon as we can.